Well, now we come back to this call center example, where, as I've described it, you've got one database which you never touched. You've got the second database, which, in the same way you do with this transient logical standby scheme, you've instantiated, taken off tracking, made all the changes you want in it, as you would in normal downtime patching, brought up again, caught up the tracking with the transformations that you need to do this example of refactoring, right? All that. Now, we also established that you need bidirectional synchronization. Let's assume you're doing this today, and let's assume you're using Golden Gate, which is the current favored way of doing this redo mining and replaying of SQL, even allowing for interventions that do transformations. Well then, if you read the book, the glossy book on Golden Gate, it'll say it does bidirectional synchronization, no trouble. So then, you set it all up, and then you think about it. Maybe you don't think about it, and you just get funny results. Maybe you just do this following thought experiment. This is the thought experiment, the call center one. Someone new comes along, really, really new. They haven't used the system at all before, and they have to volunteer on the phone a nickname. Tell us your nickname. What do you want it to be? John. Oh, I'm sorry, John's taken. Think another one. How does that message that John is taken get produced? It is produced because there's in the business world, a unique constraint on the set of all nicknames, yes? But no one would dream of selecting out all the values and using some program to run through them and so on. You just rely on how an Oracle unique constraint behaves. You try to put John in the table, and if you get the unique constraint violated error, you handle it in your application code, and eventually you report that as, I'm terribly sorry, John is taken, have another guess, yes? And in this example, it's all being done by the guy at the call center speaking to you, right? Now picture then the case that two call center guys are each in flight, each with a different person phoning in, one on the old and one on the new, yes? In normal life, when there's no upgrade going on, it's simple enough. If each of them has the person at the other end propose John 17896, surely that's going to be unique, and each of them tries it, it's that situation that I just described with the SQL pluses, right? It'll just work out that one of them will happily succeed, and the other one will instantly know, just as if John 1 to whatever I said it was in there yesterday, that it doesn't work. No problems. What happens, though, in this situation of concurrent operation of old and new, with the Golden Gate doing the synchronization in both directions, in this race condition? I'm sure you can guess. If the race condition is racy enough, so to speak, then each call center operative will press the button for putting in this supposedly unique name, and in the database where it's to go, it will succeed because the other row hasn't come across, or the other row hasn't come across, because the synchronization is based on mining redo, and redo is generated only after commit, yes? So I think you've seen, just by pure thinking, what some people would only notice in real life when they hadn't thought about it in advance, that if you use a synchronization scheme between two separate databases that's based on redo mining and SQL reconstruction, with the transformations, not that the transformations matter in this proposition here, then you're bound to be at risk of getting conflicts, as they call it, right? Which you don't get in normal life. In other words, meeting the zero downtime application upgrade goal this way brings quite a cost. Now, I should point out that in the early 2000s, before Oracle had bought Siebel and before Oracle had bought Golden Gate, those two together made a collaboration and charged customers of Siebel a noticeable amount of consultancy fees to do zero downtime upgrade using exactly that method. And guess what? Of course conflicts occurred, and guess what? The consultants charged yet more to do some manual process of conflict resolution, negotiating, trying to sort it all out. So there's a existence proof of people having thought that that might be viable, and even insisting it was viable. Of course, they would insist that because they were making a fair bit of money out of it. Now then, the stage is really set because we're now ready to see what requirements a proper solution to the goal we've set need to have, what properties a proper solution needs to have. It must allow the illusion of setting up a whole new separate database in which you can make all sorts of changes you want while the people using this don't know you're doing it. It must allow, when it's been changed, everything in the new one to get up to speed completely with what's in the old. Moreover, it must allow mutual bidirectional synchronization in the classic transactional model. Okay? We've just deduced that Golden Gate is no good because of fundamental laws of physics, or at least fundamental properties of redo mining. So how can we do it? Well, there's one obvious way. Don't use Golden Gate, use database links and two-phase commit. So you could do that. You could put a trigger on every table each side, and when the trigger fires, you could just reproduce the same insert, update, or delete in the corresponding table the other side. Most of those would be just brain dead. But for the few tables involved in refactoring, if there was any of that, there'd be the transformation. One in one direction, one in the other, just as you would have had to have done in Golden Gate anyway, by the way. So there we've got a perfectly semantically sound solution. So we've found a way that we can meet the basic functional goals very robustly. Problem is, there are non-functional goals as well. One of them is that you ought to be able to set up this second copy, this secret copy, relatively quickly, because you're going to be doing this fairly often. It's not going to work if you have to, put in forms and commission stuff and get permission to have new kit and all that and the time it takes. And anyway, you also want the whole thing not to bring the system to its knees with respect to response times and so on while this patching activity is going on. And I'm sure you can see that triggers on every single table and database links and two-phase commit is just not going to have an acceptable performance characteristic in any real-world situation. Let's face it, no one cares about zero downtime upgrade unless it's a fairly important application. And I don't think you find fairly important applications that haven't got lots of data and lots of concurrent use. So it kind of says itself, doesn't it? So then we've just got to take account of the non-functional goals. So now we can state exactly the properties that a real solution must have. Here we go. Must be such that you get the illusion somehow of a second version of your whole world, an independent version, which starts off identical to what you had at the beginning. But it must take essentially zero time. In other words, it must use some variation on the well-known copy on change, sparse copy idea, right? And then it must allow genuine transactional synchronization with ordinary performance, just as you used to in the case of an ordinary database and no upgrading going on, which is really to say everything must happen in a single database. So now I can just repeat it another way. I can say that the solution to the zero downtime application patching, application upgrade problem, at least for the Oracle database backend of the total application, has to be this. Some technology that lets a single running Oracle database appear to the outside connecting clients as if it's two separate databases. It must produce the second copy more or less immediately, using therefore some kind of sparse copy notion. And it must allow synchronization inside the one database in the classic way, which I guess you can guess is going to involve triggers. We don't want to have triggers on every single table, of course, so you can guess that it's going to be in the nature of the sparse copy, that if there's a whole table that's not affected by the present endeavor, it's just going to sit there untouched and be visible in both worlds. Yes? So now we've got the basic idea. Are you sort of, is everybody on track? So it's a little bit hard to tell whether I'm losing you or boring you stiff, because this was blindingly obvious. And you wonder why I've taken 50 minutes or whatever it is, 30 minutes to get that far. No, 50 minutes. Well, I'm going to assume that whether or not you got bored, you're still with me then. Yes? Yes, right then. So the final thing is, there was a period in time when the Golden Gate Siebel business that I mentioned was out there, people were doing it. At the same period of time, eBusiness Suite were not doing that. At that same period in time, the early 2000s, customers of eBusiness Suite were hugely annoyed, you know, rioting in the streets because patching or upgrades could cause them downtime, sometimes measured in hours, sometimes even measured in days, right? And so you can imagine the big super executive top of the whole tree of people who produce eBusiness Suite had words with the big corresponding super top of the tree in the database world. I'm sure you know, and that's Andy Mendelsohn. And the eBusiness Suite guy said, it's your fault that we're getting all this lot, fix it. And you could imagine Andy Mendel saying, oh, come on, you know, we'd need blah, 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 everything I said. I'd have to build that. That's going to be too expensive. I can't do that. I've got other things to do. Why don't you use that Golden Gate thing, like Siebel? They seem to be happy. And, you know, some negotiation. And obviously, the eBusiness Suite people said, no, we're not going to do that. We don't even want to start thinking about that because we can prove to you a priori, like I just did to you, that that approach is total bollocks. Yes? Therefore, you, Mendelsohn, have to build something. So he says, well, it's going to be expensive. And after some toing and froing, someone even higher up, of course, agreed that that expensive product to build that thing, which we've just characterized, that didn't used to exist, be done. Yes? And it was done, and it was quite an endeavor. And one thing that absolutely took place was that, you know, people down lower in the whole food chain, the real workers in the e-business world and the real workers in the database world, worked in very close collaboration, just as in any business and solution provider scenario, to make sure that every single patching and upgrading scenario that they had in their back catalog, which of course everything they'd ever done, could be fulfilled with zero downtime using whatever we invented, yes? And now, just to finish at this abstract level with an observation. The vehicle that brought the solution, of course you know it's called edition-based redefinition, but you don't know, unless you've heard about it before, anything at all about how it actually fulfills those requirements I just told you it must have. That solution, EBR, came with Oracle Database 11.2, whose general availability was announced at Open World 2009, okay? Which is a long time ago. So one thing you can say about EBR is it's now been around a long time. Another thing you can remind yourself is that it was built exactly for eBusiness Suite. They, of course, did all sorts of investigation, prototyping stuff with the not yet released version of the database, but they started their adoption in earnest only when the thing that they were using was fully baked, in other words, when it was in production. And it took them until Open World 2013 when they were able to announce that eBusiness Suite release 12.2 brings edition-based redefinition, and from that moment on, all upgrades and patches to eBusiness Suite are going to be done using that technology, okay? Now that is itself 4 years ago now. Now since then, there's more and more and more people, customers of eBusiness Suite, using that. And even big famous names that you've heard of, I guess because we're recording this, I won't mention anyone specific, but you could imagine large vendors of colored dark fizzy beverages and large entities in the Silicon Valley famous for providing schemes for you to send money to your mate in some way or other, right? Entities like that use this eBusiness Suite thing, and they are hugely demanding. So I think now we can just, without understanding anything about how EBR works, we can conclude this. One, it was not present at some time, then it was present. And it was only present as the result of an expensive project. That means everyone agreed that there was nothing that would solve the problem unless that was done, right? Next thing, we can conclude that with respect even to the back catalogue of all the e-business suite patches that they've been doing, and now the forward catalogue from 2013 onwards, it's functionally complete. Next thing we can conclude is that given the high profile of all these customers, and given also the enormous testing, you know, let's say emergent testing that the e-business suite did while they were adopting it, we can say that the likelihood of hitting an undisclosed bug in the EBR subsystem, or for that matter, the likelihood of hitting a known bug that's not yet fixed, is no greater in the EBR subsystem than in any other corner of Oracle. And the short way of saying that is that EBR is mature. Some people say they prefer to use robust, whichever word you like to use, yes? Mature, robust, they imply no greater probability of suffering from known bugs that are not fixed or previously undisclosed bugs than anything else, right? So EBR is functionally complete, robust. What about its performance characteristics? We can also conclude, without knowing anything about how it works yet, that when you're not using it to do patching, but when it's kind of latently there, ready to help you when you need it, it has zero impact on the performance of the app. Otherwise, there'd have been complaints. And we can also conclude that even when you're using EBR to do zero downtime patching, whatever performance it has, whatever performance impact it has, and there's bound to be some, because after all, you're stealing resources from the normal community of online people to do yet something else, whatever impact that is, it's so slight that no one complains about it, right? In the big mess of everything, it disappears in the noise. So that's a hugely critical realization we've come to already, only by talking, yes? And to complete that picture, at the following Open World 2014, an engineer from Salesforce, you've heard of them, gave a talk on how happy they were with their use of EBR. Next year, American Express did the same. Following year, 2016, a company called MoneyGram, I expect you've heard of them. They have a scheme for sending remittances back home from workers who are working abroad to their disadvantaged families back home, you know. They're using it. And a cell phone app, you may have heard of it, called Move It, also use it. They gave a talk at Open World too. There are many others, but that's enough, you know. That's a proof, existence proof of the final part of the jigsaw puzzle, which is however hard it is to understand it, adopt it, and use it, it's not that hard because these people managed it, and they managed it without explicit hand-holding. You might say, it was okay for e-business suite because they had the brain power of the database group holding their hand all the time. Maybe they did, I don't know. But the outside people that I just mentioned, Salesforce, American Express, MoneyGram, Move It, they just did it by themselves. I didn't even know some of them had done it until I got to hear about it after the fact. So that's a convenient place now to take stock. I've set the stage. How long did it take me? Something like an hour, about the hour I said. What did I say I'd do? Wave my hands and talk against the background of one slide. I met that promise. And I think you appreciate now the following. I hope you do. Whatever you think about EBR when I explain it, whatever you might think, oh, that'll be bad for performance, or oh, that's too hard to do, or oh, that's a bit ugly, surely it should be. Whatever you think about that, EBR works, and nothing else in existence does. And you might also like to note that it works only inside Oracle database, obviously, and no other database has got anything remotely like it. They've just not even attempted to do a solution. So then, how will I spend the rest of the day? What I've done now is number 2, in case you were any doubt. I just did that without showing, except I haven't stated the solution in its most compact form, and I'll do that in a second. What about the scope of the presentation? I've already set the stage for you to understand what I mean. I'm going to talk about how EBR inside the Oracle database lets that Oracle database backend deliver those properties of solution that I said it must have. I haven't, in my discussion so far, said anything about the total stack. I don't want to spend time on that. I want to focus on the database. But I can't leave you without a picture of the whole total stack. So I'll do that in a moment, okay? And when I've done that, we'll be ready at number 3 to look again at that case study only slightly more neutrally with less flamboyant vocabulary. And then we'll hit on the teaching. So that you know what I mean by the teaching, the addition and so on, let's get to this slide now. And this, okay? I've talked my way through everything that I didn't bother to show you on the slides. I said that among the properties that a solution must be to let one database manifest to the outside world as if it's two, right? Which is another way of saying there must be two secret spaces within one database. How are these secret spaces named? How are they separated from each other? That's what additions are, right? I haven't done any explanation yet. I've just given you a word to go with the notion, right? The secret space idea, that's additions. The old version is in the old edition, the new version is in the new edition, right? I also said that the scheme has just got to be some kind of sparse copy scheme. In particular, a humongous table that you don't touch in the present patching or upgrade exercise just should be there. You don't want to have it twice, and just by virtue of being there, it's self-synchronizing. The notion of synchronizing vanishes. You don't have to synchronize between two occurrences of the same thing because there's only one, yes? In other words, we've kind of, to put a name on it, and to get slightly ahead of myself, whatever this addition business is, tables are not going to be in it, but they're going to be projected into it so that you can do refactoring stuff like I described when you need to, and the projection mechanism is the additioning view. Another way of saying that second bit is that whenever you want to do table structure changes, you're going to achieve it exclusively by addition. Maybe add another column that the old world doesn't see, maybe disguise a column that the old world is seeing so that the new world doesn't see it, maybe replace a table with a whole new different version of itself where the row count is different but the semantic content is the same, all that lot, and project those tables into the ordinary world of additions using an additioning view. And then finally, we need some synchronization. Not surprisingly, it's going to be done with triggers, and our triggers are a little bit special. They're everything you know about triggers and a bit more, and we call them cross-addition triggers. So I've just given you the labels now, the signposts. At the end of the day, you will know everything that lies behind that. You'll know exactly what this notion of addition is. You'll know exactly why we need this thing called an additioning view and everything about it. And you'll know about synchronization and cross-addition triggers. So that's where we're going. Now, it's now roughly an hour since I've been in flight. I'm not quite sure what you've proposed about coffee breaks, but I think it would be nice if I can do the next little piece, which is this thing across the whole stack, which would take 10 to 15 minutes, and then and only then have a coffee break. Does that sound okay? Yes? Can you stand another 15 or so minutes locked in your seat? Right, okay then. So this is where I tell you in adequate detail how the whole thing works across the stack. That, in other words, I convince you that given the bit in the database, the rest of the problem is relatively straightforwardly solved. The hard challenge was getting the database bit in place. And you can see there's a word on the top of the screen, hot rollover. I haven't used it yet. By the time I've been through these slides, I will have given it a proper, useful definition. So go back to that scenario that I began with, where there didn't used to be an application at all. And it was considered and specified, and then its external behavior was invented and described, and then the design spec came, and then it was implemented and tested in all kinds of ways. While there so far wasn't even a production version, then it was installed into the production environment and turned on, right? We're seeing the whole thing warm up here for the very first time. So along comes the very first user, does the URL, goes to a component called the traffic director. Why have I got it there? You'll see him in a minute. What does it do? You'll see more or less in the next sentence. You're already familiar with some component of roughly that position in the picture, taking responsibility for authorization, right? The first thing that happens is a challenge needs to go up. Who are you? And give us a password, that kind of thing. Maybe something about your mother's maiden name, for all I know. That sometimes comes into the picture too. Maybe the first, the seventh, and the last but three digits in your secret code, or whatever, you know. But you come through that, and then you're in flight. And note, I mean, you know this, but it's significant. You're challenged once, and something represents the fact that you succeeded and that you're now authorized, and you remain authorized without further challenges for the duration of your session. Yes? I expect you can guess that that's represented by some kind of cookie holding some kind of magic GUID type of thing, globally unique kind of thing, which is a key back to something that represents who you are and the fact that you're authorized. And this thing passes up and down with the URL requests as a cookie. Are you all generally familiar with that notion? Yes. So in this scheme, there's one extra ingredient in that first initial sign-on. It's that the traffic director, I'm going for simplicity to say that this traffic director component subsumes the task of authorization and determining which version of the application to send you to. Of course, that's a trivial choice at the moment. There is only one. So you're sent to application version 1, but in the same way that this cookie that goes up and down reflects the fact that you're you and you're authorized, it reflects the fact that for the duration of your session until you end it in your own sweet time, you're on version 1, right? You're on V1. You're affinitized to V1. I'm sure you can imagine how that can be done, yes? So then traffic is built up, and now we're kind of in flight. This is normal operation in the world of V1. Now what happens? Weeks pass. I don't know, maybe a couple of months pass, and then there's an impetus to do patching, and but let's say that eventually there's an impetus to do real significant application upgrade, right? And that's what we'll use in this illustration. So what we need there is a radically changed application backend. Application backend is shorthand for the set of artifacts inside the Oracle database that you put there to implement the backend of your application, right? That's needed, at least. Other things will be needed, but that's needed. So bang, you do it, using the magic that I'll explain. But I've already promised you that you get to that result, right? So now we have one database which to the outside world gives the illusion of being two, one at V1 and one at V2, and all that synchronization, it's happening. And it's significant to put it in that sort of externally facing way, because someone somewhere in this whole picture, maybe some of you, if you're lucky enough, will be pitching this story to someone in the place that's going to adopt this technology, where they want to understand how the whole thing works, and where there'll be an army of people whose whole concern is limited to exactly, if this shows up at all, this part of the world, the middle tier, this and so on, right? They're people who operate up there. And for them, the database, this thing, is just a place they get to with the famous 5 facts. You know, the famous 5 facts that you need to get to the Oracle database of interest are listener location, listener port, service name, username, password. 5 facts, yes? And for their purposes, they need to put down this application tier business once and for all, semantically compatible with version 1 here. It's version 1 of the database, version 1 of the database backend, version 1 of the application code. They know each other's properties. They deal with each other very specifically. And this guy here, these connections in the connection pool are all connected using the 5 facts that the engineers up here were simply told. Put these 5 facts in a file and it'll all work, yes? And they don't need to care how the database works. They just know it delivers the functionality they need. Now then, this here, this pink business, yeah, can't separate it, but you know what I mean, is so radically different semantically by intention from the gray business that clearly it's going to need its own separate middle tier installation, yes? It can't not. The kind of functionality that you've brought in extra needs representation on the browser screen. It needs code up in the UI generating layer, which is the browser, yes? Now, what happens at this moment, all the people who are watching this behind the scenes declare, now we are ready to admit new sessions into V2, while as we've set it up, we understand that in-flight sessions on V1 will continue until they're ready to stop, yes? So we just throw a switch in the traffic director, and now you understand why it's called that. Switch thrown, Next guy comes along, authorized and affinitized to version 2. So we can see now we're in this situation where the users of version 1 don't know anything's happening. They're just working normally until they finish in their own sweet time. Where the users of v2 don't particularly know that it was built in secret. Say they'd been away for a week and they come back and they just get on version 2. The end users have the experience that they've always had whenever application upgrade has been done, with one hugely important difference, and that is at no moment are they ever thrown off, and at no moment are they ever held back from starting, right? It might be that they exit and return immediately, and suddenly they've gone from old to new. But at least then, they were warned about it, and before they really start working in their just started session, they can familiarize themselves with the layout. That's notably different from it happening in mid-flight, which would be unacceptable. So this then is where we use the term hot rollover. See, the traffic's now built up. From the point of view of the end users, there's no rolling anywhere, right? But from the point of view of the people behind the scenes watching what's going on, they see the total population of end users rolling over from 100% on the old to 0 on the new, through to, 80 on the old, 20 on the new, 50-50, 20 on the old, 80 on the new, 0 on the old, 100% on the new. And of course, they are seeing then rollover, hot, of course, meaning that there's no downtime involved. So now you see why we use the word hot rollover. Hot rollover is the name we give to the period when the old and the new versions are in concurrent use, and all that bidirectional mutual synchronization in a fully transactional fashion is taking place. Yes? Okay? And then, of course, the grey people eventually die away on their own schedule, and new people come along and they're sent to the pink, and eventually you reach this stage here. Okay? And in this moment, the behind-the-scenes people understand that kind of by construction, no new request will ever again be sent to application code in the middle tier at version 1. It's finished with, so they can take it away. And again, they realize now by construction, no requests will ever be directed to the old version of the app in the database. It's now redundant, so it's taken away. And now we see that normal life is regained. And in a sense, this is the pattern you always had before. Before you had normal life, just only one version of interest, downtime, everyone biting their nails, watching the clock, really stressful. Let's hope it finishes in reasonable time, and let's hope it succeeds, neither of which outcomes are necessarily going to be the case. And then you come up again, you're now normal life regained, but you're in version 2. So it is with zero downtime patching. Normal life, there's only one version to talk about. Interesting life, but not stressful, just, you observe it, it's quite interesting. Old and new in concurrent operation where the whole population is rolling over, hot rollover from 1 to 2. And then normal life regained. Now the critical thing to just accept now, I'm going to tell you this, but later I will make it crystal clear by a specific example, vividly clear to you. In general, the functionality, the full functionality that you intend by your upgrade cannot be exposed until all the population have left the old world, okay? In many cases, that's not the case, but in enough, it is. It's the general case. So just as with old-fashioned downtime patching, your aim is to get through that patching process as soon as possible and get to version 2, so it is with EBR. We needed the ability to have concurrent operation of old and new simply to meet the zero downtime goal. However, we want to get to version 2 and everyone off version 1 as smartly as possible, because it's only then that we can finally say we've got to version 2. I'll make that clearer later, yes?
Is there a going back possibility?
Is there a going back? No. In general, there's not. And I will illustrate that too vividly as we go through. In special cases, of course, there might be. So then, there we have it. I'll just go through that quickly one more time because I think it's quite vividly, and then I'll give you a little anecdote and then we'll take a break. So just watch the animation. I won't give any words. I think you've said it all. Just see it going through slowly. Someone comes on one. Someone comes on one. Traffic is built up. This is the magic moment. Bang, the magic is done. Bang, you need a new one of them. Now the traffic director on, the population drifts over. And now that's just history, take it away. That's just history, take it away, normal life regained, okay? Now, the anecdote to finish with is this. Some businesses who have internet-facing browser presence, where ordinary members of the public use it, are able to compute the opportunity cost that accrues from downtime fairly well. I'll give you one example. The car rental business, right? I'm, for historical reasons, kind of some status with Hertz. So when I need to rent a car, my first preference is to go to the Hertz website. And almost always, I just do what I always do and get a car. Sometimes I need to do that at short notice for tomorrow, when I didn't know a moment ago that I did need to do that. I'm sure you've all had similar experiences. Now, I don't mean to say anything about Hertz specifically, it's just a name you've all heard of. If I went to the Hertz website in such circumstances, I need a car. Suddenly, I didn't know I did a moment ago, now I need it, and I need it tomorrow, and the site was down, what would I do? What would you do? A or B? A, oh, well, I'm loyal to Hertz. I'll leave it for now, set a little buzzer, try again in an hour. Oh, you know, worst case, I'll leave it till the morning. No, of course not. You don't miss a beat, do you? You think, oh, well, I'll try a different one. Who shall I try? Avis, I've heard of them, you know, and if their site is up, and if you succeed in getting your car fixed, job done. Worse than that still, for Hertz, if you get the car, and it's nice and clean and, you know, quite an exciting racy model, and you drive it a bit and you bring it back, and somehow the whole return experience was a lot easier. You know, you didn't have to stand in the freezing gale force wind in the rain for so long, and the trip on the bus to the airport terminal was actually easier. You might, next time you rent a car, think, well, I'll do Avis again, yes, yes. So that model is crystal clear, and car rental companies watch this stuff with eagle eyes, and of course they can attribute the downtime to different sources. So I had some dealings with a big famous name company. You'd all have heard of it, but I'm not going to say it, and it may or may not have been one of the ones I mentioned. You just have to guess, but you've heard of it. And they had managed to work out what the opportunity cost was per year, exactly attributed to outages caused by application patching and upgrade. Never mind the rest of the story, you know, patching the Oracle database, whatever it might be. They had different metrics for that. They had an explicit metric for outage. Would anyone like, let's just show a show of hands. I'll give you a logarithmic scale, and I'll start with a big number. The opportunity cost is 1 million a year, 3 million a year, 10 million a year, 30 million a year, 100 million a year, 300 million a year, right? That's a kind of logarithmic scale. Let's just go through it. I'll go on the ends. Who thinks it's 1 million a year? No? Okay, who thinks it's 300 million a year? Okay, we'll chop those off. Who thinks it's 3 million a year? I guess no one's going to think anything. Who thinks it's 100 million a year? Okay, 100. Who thinks it's 30 million a year? Yeah, oh, well, there you are. Maybe I set it up, you know, like these stage hypnotists. But yes, 30 million a year. Now, how many in this room? I was told it was going to be about 40. Let's assume you all earn, what would it be now? 5 million, is it? 5 million kroner a year? Well, okay, let's come down a bit. 2 million kroner a year then. 40 times 2 million is 80 million, isn't it? Kroner, which is less than $30 million. Yeah. So an outfit like that could take on this room and pay you all more than you're presently getting and still have change to spare, yes? But what happened in this situation, this is just a salutary tale, is that when we discussed this thing, first thing I should say is that I had a discussion with specifically the database people. And they understood it, and they were convinced that EBR worked, and they accepted it was robust and bug-free and on and on and on. And they, you know, lights in their eyes. Gosh, if they did this, they would become the heroes, the people who, you know, rescued the 30 million down the toilet every year. And what happened was the project never happened because the people doing the middle tier who, once they heard that where they would have to do this, have a second one by the side on some kit that they didn't normally have that was big enough to have the second one by the side. They said, well, we don't do that. Well, I know you don't do it, but you want zero downtime, surely. So you have to do this, but we don't do that. And the whole thing just stopped at that point. So that's just a warning to you to how to approach various discussions you might have. And let's say to start, if there's a serious interest in adopting, I'll put it another way, if there's a serious interest in meeting the zero downtime goal, you can go straight to this picture, right? Make sure everyone in the outfit is signed up to doing things differently in some way. And if the middle tier people are all for it and see it as nothing, then you can really get into detail on the database. But don't waste your time, getting everyone gung-ho on how it's all wonderful in the database, only to find the thing evaporates. And this high-level picture, I believe, should be accessible to even the most non-technical person who's semi-technical, high up in the management. Would you think so? Yeah. And just the last thing to say in this space, and that does complete the picture, loosely speaking, there's two kinds of uses of Oracle database on the planet. There's the style I lampoon in that paper that Matthias was so kind to mention. I call it the bag of tables approach, or the no PL/SQL approach. The Oracle database is treated as little more than a bag of tables. And that means that everything there is really that brings character, brings the nature of the application to bear, is in middle tier code, right? And the tables more or less are fairly unchanging, except in extreme cases of upgrade. That means that a typical patching event in such a bag of tables case is achieved entirely by middle tier code changes, and the back-end database stays unchanged. So that would mean that some people are already doing this model, right? They've already got the traffic director. They've already got the two versions of the middle tier. The only thing they haven't got is the two versions inside the database. Such a shop, who's already demonstrated commitment to zero downtime, might well easily be convinced to adopt DBR for the case that they do refactoring in the database or structural changes like adding new columns for new purposes. So see what I mean? It all depends who you're dealing with. Right, I think that's a good place to break, because next we're going to get on to the case study and then the teaching, which is telling about the addition, the additioning view, and the cross-addition trigger.